Hi, Dorien.
Hi, Anand.
Today my guest is Dorien Herremans. She's an assistant professor at the Singapore University of Technology and Design. She works with music generation systems using artificial intelligence, OR, machine learning methods. She has many important contributions in the field. I had the privilege to work with her in one project involving OR and music. I think it's safe to say that she's one of the main researchers currently working in this area. So, Dorien, thank you very much for accepting the invitation. And how are you?
Sure, it's my pleasure to be here. I'm very good, thanks.
So, is everything all right now during the pandemic over there?
Everything's good, and I believe I'm calling to you from the future, so everything will be good the next day. Don't worry.
Yeah, hopefully. So,
yeah. No, things are pretty good here in Singapore. Yeah, we're just locked down for the last year.
yeah, I wish I could say the same for us here in Brazil, but that's another story. So, you were in Singapore now, but you were originally from Belgium. So, were you born in Antwerp?
I was actually born in Hamel, which is a small village about 20 minutes from Antwerp. And I grew up pretty rural environment and went to college in Antwerp.
Oh, okay. So you spent your childhood and teenage years in this rural area, or you went to the city before?
No, yeah. So I spent my childhood in the more rural Belgium. Yes, it was a very nice place to grow up. Lots of fields, lots of places to play, and yeah.
Right. And did you start learning any musical instruments, or had any former or any musical training at that time?
Right. Yeah. So when I was a kid, I immediately started asking my mom if I could go take some instrument class. It took a few years of asking for it, but then finally, she sent me to take flute lessons. I think my first choice was a piano, but we lived in an apartment back then, so she said it wasn't possible to get a piano. And the violin wasn't particularly my mother's first choice because of the way it can sound when you're practicing. So we ended up on the flute, which I still sometimes play now and then.
Oh, cool. So
Yeah.
you learned a little bit of flute, as you said, or you really like played in an orchestra or in musical groups, or which was just a hobby?
No, so I went to the music academy and we played in the orchestra. I played in a flute ensemble and we performed. And we did a tour of nursing homes to perform. And then, other than playing flute, my dad used to play guitar a little bit, and the guitar was sort of next to my bed from a baby on, and so I sort of taught myself to play that guitar. And when I became a teenager, I switched from a boring flute to the cool guitar, and played Nirvana songs in my room.
Oh, yeah. But did your parents complain about the noise, or they understood that it's as a teenager you have to experience those type of things?
No, they were very accepting, yeah, and they could tell. I think guitar was sort of my friend or my emotional company throughout my teenage years. We used to go on holidays, during the summer, and we'd come back, and before I put away my suitcase or take off my jacket, I would be playing my guitar.
Right.
Yeah.
Yeah, I can relate to that. I also I didn't have any formal musical training, but I to this date I play the guitar as much as I can. It's very. It's also I have a couple of them here, and so it's something that it also accompanies me throughout my life. Eventually, you explore other instruments, right? So ukulele, piano, and all that. I think you did the same, right?
Yes. After actually about 10 years ago, I thought well, sometimes I pick up the flute, but it'd be cooler if I play saxophone. So then I got a saxophone, and because it's sort of similar anyway, so that I have that. I play a little bit of piano as well, although it seems I don't have a lot of time for that right now. But yeah, still every day I try a few minutes at least.
Yeah. Great. Do you remember that I asked you to play Arthur's theme, that Best You Can Do song?
Yeah.
And I think
Right. Yes.
I love that the sax solo from that song.
Right. They had like 5 flats. Yeah.
Great. And okay, you didn't pick music as an undergraduate course. You went. What did you do then?
Yeah. No. In high school, I studied economics and mathematics. So, going to university, I became a business engineer. I'm not sure what drove that. I think I do have an aspiration to be a little bit entrepreneurial. But yeah, so my degree is in business engineering and with a major in OR.
Okay, so your first contact with OR was during the undergrad. Do you remember the first courses you took?
Well, first I took the elective operations research or advanced operations research. There was like linear programming and meta-heuristics course. Yeah, those were the main ones in that major.
Oh, okay. And you decided to follow the path of doing OR in the master's right away from after finishing the undergrad, or do you have you work somewhere before joining the master's?
Yeah, in Belgium back then, it was before the Bologna Agreement was signed, where masters were put on an equivalent level throughout Europe. So I actually took a 5-year master, and which included the bachelor. So it was one continuous streak, and my specialization was on both OR and computer science, so management information systems, which I think was a good combination, because OR typically involves some programming as well. But you're probably wondering how I got into music then.
Yeah,
so yeah. I think by the end of the last year, I got sort of tired of the economics, and I saw all my fellow students. They were getting jobs at all the consultancy agencies, and when I was 24, I wasn't really ready for that. So when we were about to pick our topic for our master thesis, there was this list of topics you could choose from, and one was called music and meta-heuristics. And at the moment, I had no idea what meta-heuristics was. But I was like, music, that sounds fun. I'm going to do that. So it turned out to be a topic proposed by Kenneth Sørensen, which ended up being my PhD supervisor in Antwerp. And he just put the topic there because he saw a presentation at a conference on the topic of OR and music. And when I dove into meta-heuristics, it was actually very interesting. And back in those days, over 15 years ago, I think a lot of exploring still needed to be done in the field. And I just thought it was very cool. For my master thesis, I ended up doing a taboo search algorithm for composing some simple melodies.
All right. What about coding? At which point you started learning? Because from your undergrad course in more like economics and all that, I don't think there is much of an emphasis on that. So did you learn yourself, or do you take courses?
Well, I took some courses at school because this business engineer is a very strange, how's it called, direction, which I think they only have in Belgium. And it's basically a 4-year economics degree with 1 year of engineering courses. And the engineering courses, I mostly chose the computer science ones. So we had Java programming and Pascal programming and things like that. Yeah.
Okay, so you had some training regarding programming and coding.
I did, although I feel only later in the PhD I really had to really learn that, like the C++ and all those things.
Right. So did you submit the results from your master's to some journal or conference?
I didn't. I have the thesis online, but it's written in Dutch, so it was actually
Okay.
never really submitted anywhere.
Okay. So when did you really work in your first paper? Do you remember?
It wasn't until I went back to do the PhD. So I actually spent a few years in industry and working as a lecturer before I went into research. That's perhaps a different story. Because when I graduated, I needed a break from everything. So we decided to move to Switzerland, and I lived in the Alps for a few years.
But wait, you just decided, oh, I'm going to Switzerland like that? Or did your family
Yeah.
move, or you moved by yourself?
I moved with my partner, yeah.
Okay.
And she had a job, but I didn't. And it turns out it's kind of hard to find a job in you living in a small mountain village. But I did end up getting a job as a lecturer at the private British university up in the Alps, which was great. It gave me some teaching experience. But after a few years when we moved back, I very randomly bumped into Kenneth Sørensen again in a bookstore. And we started talking about the PhD again. And when I started doing the PhD with him, then we worked towards our first publication, which was a variable neighborhood search for counterpoint generation.
Counterpoints, yeah. So before we continue into that, in Switzerland, do you remember what did you teach there?
Oh, it was some very basic computer science courses, like talking about how to make websites, how to work with Excel and PowerPoint, and the course on 3D computer animation as well.
That's pretty random.
It is. Well, it was. I was working in Les Roches, which was one of the top schools in the world for hotel management. So I was basically teaching all the computer science they got.
Right. And what about the industry? You had a job in the industry there as well in Switzerland, or you're working remotely?
In Switzerland, I worked. So I had my sort of own web development business, and I made PHP websites for people. Right. And then when I moved back to Belgium, I worked for Van Breda International, which is an insurance company, and I worked as the webmaster there.
Okay, so you have a lot of experience with web development then.
Yeah.
That's nice. So now you told you bumped to your into your advisor. You met him in a bookstore, and then you decided to continue.
When I was working as a webmaster, I was sort of getting bored a little bit, and I wanted something intellectually stimulating again. So I had been toying with the idea of going back to school, and then running into Kenneth just sort of seemed to make sense. And when I talked to him about a topic, he was saying, well, there's this idea that we could do a routing problem for money transports, how to build a safe route by stochastically varying the routes. And when he was suggesting that, I said, well, or I could do music. And Kenneth's the best guy. He was like, sure, you want to do that. So that's when I got back into that.
Yeah, so what actually drove you into doing research from the beginning was music then? You started in your master's, and then after you came back and joined the PhD program again, music was maybe the driving force that pushed you?
Yeah. I've always been, like I said before, it's been like my constant companion. I think music's very important in one's life. And it has a thorough effect on how we feel or how we connect with people. And yeah, I just thought it would be interesting to explore something that hasn't really been explored much, especially at that moment, and to see if we can apply these things that are typically used for scheduling, routing, timetabling, and if we could apply it to something creative like music. It seemed really cool to do something creative with this.
Right. Okay, so you now had music and OR again, but was it your choice to work with counterpoints, or that topic was given to you?
No, it wasn't given to me. So when I started researching, as you all know, if you have an optimization problem, you need to first define your variables. In this case, we're trying to decide which notes to play. Then we need an objective function. This is a bit harder, right? Because maybe the objective function is we want to generate good music. Well, what is good music? And in the beginning, I thought I could perhaps approximate that by trying to match a style as well as possible. And what easier way to do it if you have a style that's fully defined by rules. And in Counterpoint, I read through these books because I wasn't familiar with Counterpoint much before that. And you have all these rules that you can quantify. You can say every big leap needs to be followed by stepwise motion in the opposite direction. It's something you can say, true or false. And so you can build a sort of penalty function that you can then optimize. So which made for a perfect optimization problem.
Right. Yeah, we did something similar with Bluche. Bluche is is sort of something that is a safe environment, if you will. That allowed us to work with rules and something that is well defined and known and accepted in the style. And okay, then you probably spend some time formulating the problem, and then you, as far as I remember, you implemented a VNS metaheuristic for that, right?
Yeah, I did. Yeah. So that was my first paper, which we sent to, I think, Journal of Mathematics and the Arts. I think we're still testing and seeing how open the OR community would be about this.
Yeah.
At least the mathematics community seemed to be very excited about it.
Okay, so your first attempt was in sort of a multidisciplinary journal, and you succeeded then. Do you remember if the reviewing process was a pain or it was smooth?
I remember Kenneth being impressed by the length of the reviews. Like it was pages of reviews with comments and remarks, which was a good thing that they take their time for this. I'm sure it improved the paper a lot. But as is always the case, if you're publishing something somewhere multidisciplinary, you can get reviewers from a very different background who expect emphasis on different things. I find that these days, so a lot of people publish in the ISMER conference, the International Society for Music Information Retrieval. And the reviewers, you can either get a musician, like a music theorist, you could get a diehard deep learning person, or you could get a psychologist. So it makes it almost that the acceptance can be a bit random, because you need to be lucky that the reviewers are in your area of expertise and they agree with your methodology and how you wrote the paper. But
yeah, I experienced that with our own work. We got that. I think it was probably the longer review I've ever got, and it's in a way it's very nice that the person took interest in reading and providing helpful and detailed comments. Sometimes at the same time asking a lot of details, and it can be a bit hard to meet all the demands. Did you present that somewhere?
That first work, I presented it at Orbel, for sure. I think that those are the Belgian OR conferences, right? So we always used to attend that as a group. And I think later on, because I published it in this Journal of Mathematics and Arts, they invited me to this conference they were holding in Seoul in South Korea. So I presented it there as well a few years later.
Oh, great.
Yeah.
And when you presented for the first time, how did the audience react?
Well, they're always very, if you present in OR conferences, they're always very excited about this new topic. Like, a lot of people wouldn't have heard or thought that you could use optimization to generate music. So usually the reactions are quite enthusiastic.
Yeah, that same thing happened when we presented our work here in, I think, 2016, because it took a while until we got some results. And then Nailson, which is the main author, which, by the way, looks like Ronaldinho Gaúcho, the soccer player. When he presented, the room was packed, and the audience was really enthusiastic about it. It was really nice that I even heard in the corridors, I'm going to see this guitar solo work. What is it about, and all that. So you get, I said, whoa, finally someone is getting interested in something that I'm doing. And it's very nice. And then how hard was for you to complete the PhD, and how was the process? And I would like you to comment about the challenges in terms of implementations.
So I think I didn't think about the bigger picture maybe at that moment. I was just creating a little algorithm that could generate music. And I spent some months implementing it, then writing it down. And sort of, I saw the flaws in the first algorithm, and I thought, well, it'd be great if we can compose, multiple lines of music. So I expanded it to fifth species, spent a few months programming and then publishing. And it sort of naturally came about, the PhD, in that way. But that being said, I think programming optimization algorithms can be hard. It's a lot more programming than people might expect. Looking at machine learning and deep learning now, I feel like in a week you can put together an algorithm. It doesn't really work that way with meta-heuristics, at least not in the time back in the day. And there was weeks when I just had a compile error that I couldn't figure out, and you spent all this time thinking in your office, but then finally on a bike ride or something, it just occurs to you what is it that your bug was. But in general, I don't know, maybe I got lucky that I chose a direction that was unexplored yet, because in a way, I think that can be easier. You just have to think creatively about, how can I create a fitness function for this problem? Or how can I see this as an optimization problem? But once you have an idea for that, most probably it's going to be pretty novel. So that at least is an advantage to doing something in a relatively new field. I think if you're doing something, looking at the work some of my students are doing in like emotion prediction from music, there's quite a lot of algorithms already there. So to do something, if you take the exact same problem and just want to update the algorithm to the state of the art, it's much harder and you have a lot more competition. So in a way, I feel like I was lucky in the PhD. I mean, it was a lot of work, obviously, but we had a very good, I think, work ethic at the university. Looking at other universities in Antwerp, everybody was there at 8 or 9 a.m. and they left at 5 p.m. And then we sort of didn't talk about work and we all went for drinks, which is great. And then the next morning, we're all back in the office at 8 or 9. And somehow looking at other universities in London or even here in Singapore, it seems like students or researchers just sort of have very late hours or irregular. And for me personally, I like having that sort of separation. Mm-hmm. I think it's a European thing that we want to have this dedicated time, not for work.
Yeah. I see what you mean. Yeah.
Yeah.
So when you code something that generates music as an output, sometimes when you try to debug, you have to hear what you programmed, right?
Right.
So how was that process for you? And how did you figure out, okay, this is starting to make sense?
Yeah. So using these counterpoint rules, you kind of have an easy way. You can see which is the mistakes, and then usually you hear it too if you listen to it. Of course, there's always the challenge of making it into a playable format, because usually I generate, MIDI pitches like 60, 62, and then there's this whole process of outputting it. Back in the beginning, I remember writing actual MIDI files in a machine learning language, so in like hexadecimal codes. Now there's these libraries that'll just sort of output it for you, so that's a lot easier now. So there's multiple factors to consider though, because one, the music can sound good. On the other hand, it should also be playable. This is something that I noticed afterwards when generating like piano music that wasn't counterpoint. And I worked with Elaine Chu, who's a pianist, who's based in London. And I generate something that sounds great, but then to have her play it, she's like, this fingering is impossible. Like, so
yes.
That's sort of another thing to take into account.
Yeah,
unless you generate or play a piano.
Same for guitar solos, right? You can't just start from one part or here and then go all the way there. You can, but sometimes can be not realistic.
Right.
Yeah.
I suppose that's why at some point during the PhD, I worked with a then undergrad student, and we came up with a piano fingering algorithm. Mm-hmm. So again, I think we also used variable neighborhood search to try to detect which finger you should play a note with in a piano score. So again, we just created a fitness function using some rules, like it's okay to do like this, but it wouldn't be okay to do that. And you just give a different penalty points, and it sort of worked because a few years later I talked to someone from Musician, the Nordic company. They make this great app for learning to play instruments, and they said they experimented using our algorithm as well. So that seemed like
that's awesome. Yeah, never told me that. That's cool. And what about the technology, if you like? I mean, you use, I suppose, C++, or did you use any other language? And combined with, like, to use the musical representation, did you use music XML? What did you do? Can you talk more about that part? Because I know that some people might be interested in working with that, but that setup at the beginning can be really tough.
It can be a bit daunting, yeah. I had a whole evolution from using like ABC notation for scores with Pascal, which is kind of a very nice language, I would say. During the PhD, I used more C++ or Java, and I believe the output is usually in MIDI files back then. But I found out during the postdoc that there's a lot of benefits from using music XML, which is a dedicated XML format that can be read by a software like Finale and MuseScore. Because music XML can encode a lot of different things. So musically as well, a C# is not the same as an A flat, right? Mm-hmm. So those are the kind of things that you can capture in music XML. You can even add the fingering information. You can add chords as chord symbols. It's a lot more rich format. These days, I work mostly with Python because we're incorporating a lot of machine learning, and everybody's just using Python. And it has some very powerful libraries for this as well. I think it took me 2 or 3 years to really get used to that because Python's quite different. But I think I'm starting to get the hang of it more. Yeah.
Cool.
It's, yeah.
So with Music XML, we also had experience. We can embed the guitar techniques like hammer on and sliding and all that. So that makes a lot of difference. It's not just a matter of putting notes in place. You have to consider all those other features. Otherwise, it won't even sound like a guitar solo. It may sound musical because you are probably choosing appropriate notes in a sequence. At the I mean, at the end of the day, you were just scheduling notes, right?
Right. Yeah, just scheduling notes.
So, but it's harder than it looks. It's not something that you just can put in. And depending on an instrument, also it can sound either good or it may be weird. And you use MuseXML based on your suggestion back in the day.
Yeah, I think it's quite powerful. And then there's some good parsers available too. In Python, there's like Music 21, and also for Java or C, there's other parsers. So the bulk of the work is done for you.
Yeah, right. That's very important. If you have access to that technology from the beginning, then you'll be able to do something that sounds literally musical and pleasant. Otherwise, it can be frustrating that you try to, okay, I want to do music, and then I can code, but if you don't know the correct tools and ways of storing the music itself, it can be annoying, right?
I think this is why, like if we're hiring researchers for the lab, it can be challenging because ideally you want someone who has experience with this music format, because there's a steep learning curve, and everyone needs to spend a few months just sort of getting used to that kind of data.
Yeah, it's if you see from the optimization perspective, it's asking one to, if you want to do, for example, advanced exact algorithms, it requires a certain amount of training to get to know the tools, the callbacks from the solvers, and all that. And of course, the theory. And I understand that in music, it also one needs a setup or a period where one gets accustomed and used to the tools and the way you code that. And so you graduated. I remember that. I think it was around 2014 or 15. When did you?
Yeah, I think December 2014. Yeah.
Yeah, and did you already had in your mind? Okay, I'm doing postdoc. I'm trying to follow academic career. I'll keep on doing research. Or you thought of going back to the industry or doing something else?
Yeah, I didn't really think of going to the industry at that point. I might have considered some music company at the moment, but I was still very fascinated by the research I was doing, so I was eager to continue on this. Yeah. And I was lucky to get a postdoc fellowship, so I could keep doing it.
Did you specifically look for a position involving music and computer science, or music and artificial intelligence, or anything related to OR was fine at that stage?
No, I think at that point I wanted to do something with music. Yeah. So the way it happened is I visited Queen Mary, which is basically the center for academic music research. There's only a few places where they have big labs. So they have one in London, Paris at IRCAM, Barcelona has a lab too. So I was there, I think for a music hackathon or something. And I gave a seminar at Queen Mary, and I met some people like Prof. Elaine Chu. And when I saw Elaine later on in a workshop in the Netherlands, in Leiden, then we talked about doing a postdoc with her, and she suggested maybe I should try and apply for a Marie Curie fellowship, which I did. And I think this was just before my PhD was due. I went to London for a few days to talk to Elaine and write the proposal. So basically we sort of pushed out the proposal in a week, and it got accepted. So after finishing the PhD, I moved to London.
Oh, that's great. Talking about finishing your PhD, how hard was to publish that work on the VNS and for the application in Counterpoint?
It wasn't so hard, I think. Maybe I misremember it. I mean, we spent a lot of time writing up the work properly, and Canada is great at that too. He really educated me a lot on academic writing. So we submitted some of this work to journals like Expert Systems and Applications. Well, our work went to Chores, right? And,
Yes.
We typically get back quite a long reviewer comment list, which I think is because the topic tends to interest reviewers, so they take some extra time to offer their suggestions. But usually after addressing the comments, we manage to publish the manuscripts.
Yeah, it was on that particular period, 2014, where I contacted you in January, and it was mainly because of that work. I was feeling a little bit bored, I think. It was a vacation period. I was at home, and I just thought, I had this thought at random. I said, is it possible to connect this or in music? So I'm very much into music. I'm addicted to that. So how can I kind of put things together? And then I started Googling. And then, to my surprise, I found that work of yours, and I took a look, and then I said, this looks more like classical stuff. I am more like into classic rock. And then how can I make use of that, and how can I do any research? And then I contacted you, and you were super kind. You answered, and then we just started discussing what were the possibilities, maybe starting with piano. And then I mentioned that my student plays in a heavy metal band. So, and that leads me to one question: is you really need some musical skills, and computer science skills, and it's not very easy to find a good candidate or even a good researcher with those abilities. And
yeah.
So, do you think that you consider yourself like gifted or very fortunate to have both abilities? Maybe.
Well, I wouldn't call myself gifted or something. I'm just like an amateur musician. I just like playing music. I'm not sure how good it always sounds. But no, I was just lucky maybe to start exploring a topic that interests me, and both in sort of an analytical way and in a way that I'm passionate about, like music.
Yeah, because if it was not for your work, I wouldn't have done anything on that topic. And you really need somebody with some reasonable amount of experience to catch the research on this field. I mean, it's like trying to do some advanced engine programming stuff, but on your own is quite hard. You need somebody to supervise you, and then when you want to put music in R, and where I will find somebody that is an expert on that. It's very hard. And you yourself, you were brave enough to be. I would not say, of course, you had very good supervision, as you mentioned, but at the same time, you had to figure out your own path, right?
Yeah. In Antwerp, I was very much the only person doing anything with music, and maybe in hindsight, that was brave. It just felt like something I wanted to do. But looking at it, there's a lot of other students I see that do need that guidance and support from their peers. I suppose one thing I've always been good at is finding things on the internet. So maybe that's how I found you as well, although you kind of found me. I think we're lucky that we can socially connect online now, so we can be in touch. during my time in Antwerp, I collaborated with you, with Daryl Conklin, who was in Basque Country. So I spent a few months there as well as a visiting student. I went to a lot of conferences and connected with people who I ended up collaborating with. So that was actually, going to conferences was a very important aspect of this. And I feel lucky in a way that I was still publishing very much in an OR field during my PhD, because it seems to be an OR you publish in journals and then you write a little abstract to present at a conference. So you get to go to a lot of conferences, even presenting the same work. In computer science, it seems to be that you just publish in the conference. So you need to have a whole paper and work ready before you can go. I find it a little bit more stressful because there's always these deadlines, and you have to force something to be finished so that you can attend this conference to see your peers. I like the OR community a lot better in that regard.
I see. Right. So tell me about your UK years now.
Yeah, so Queen Mary is a great place to be as a music technology researcher. It feels a little bit like working at a conference, because they have these theme meetings every week or multiple times a week where students are presenting their work on music technology. So almost becomes so much that you don't have time to go to the meetings because you have work to do as well. And it's a very good place to learn a lot about music technology. So for once I was in a place where I didn't always get the question, why are you doing this and why is this useful? So that was nice and refreshing.
Great. You spent a year or two in?
Yeah, 2 years about in London.
Right. And then I suppose your contract was over and you had to look for something else. And
yeah.
So you ended up in Singapore from there, or did you go somewhere else before?
No, I ended up straight in Singapore. I guess I was tired of the UK weather and I wanted to be somewhere to warm up.
Yeah.
No, well, it happened, I don't know, sort of at a great time and almost automatically, because I was working with Elaine Chu, who grew up in Singapore. She's American, but she grew up in Singapore, and she had some connections here. She knew that this big lab, A*STAR, wanted to start a group on music research. And both me and my partner at the moment both work in the same area, and we have this two-body problem. You want academic positions in the same city, preferably, and we're both sort of finalizing our postdoc. So Elaine brought us this news, and our first reaction was like, Singapore seems far away. But a lot of things were happening back then. This was 2017, so there were these terrorist attacks in Europe. And at the same time, President Trump was elected, so it didn't seem like Europe or the US was the most attractive place to be in. So we considered this seriously, and so Kat, my partner, went to work at A*STAR. I had a few more months before finalizing my postdoc, and I thought it would be a good idea to apply to other universities as well. It's not always best to work that close together. So I ended up getting a job at the university here, which turned out to be pretty nice place to be. So it's not just the weather, it's 32 degrees here the whole year round. But Singapore is this quite, you can say, rich country, and they're willing to invest in new technologies. So we did get like a grant on music generation here, which could be harder to get, I think, in Europe or the US.
For sure.
But they have this big AI program. So they want to be one of the first nations that truly embraces AI. So these creative systems, I think, are seen as part of AI. It used to be a bit more, out there maybe, but now we have companies like Spotify. So it's not hard to imagine how Spotify would maybe, well, it uses clever technologies to filter music, to recommend music. So it's not a why would you use technology for music anymore question, but it's really moved to the next level, and this is a great place to be because there is a lot of support to try out new crazy things.
Yeah. So, was it hard to find a position there at the university?
Well, sorry. It wasn't too hard. I mean, I talked to a lot of people there. I give a seminar, and they're pretty open to having me on board. The university also at the time employed Simon Louis. He's now the head of Tencent Music in Shenzhen. So Tencent, a lot of people in the West may not be familiar with it, but it's like one of the biggest companies in the world, and they're a big gaming company, but they also have a Spotify type app that they offer. So Simon's heading that. So they're already having somebody doing this audio research. So I think they're open to having more music in there as well.
You're currently ahead of one musical lab there as well, right?
Yeah, that's correct. So we have quite a number of students now, PhD students, coming from like Czech Republic. We have Hong Kong, Taiwan. We have some people from everywhere coming in to do music research. A lot of them focus on machine learning. Some include a little bit of optimization as well. I try to stay true to that because I do think some sort of hybrid form is the best, right? Although people think that they just want a neural network to do everything, including some like hard constraints or some clever algorithm can, I think, thoroughly improve results as well.
Oh, I see. Talking about that, I when we worked together, I tried to push more towards the use of mathematical programming, integer programming, and we finally ended up coding a branch and cut for that purpose. And I feel that when we used the optimization, we kind of knew exactly what we were doing, and we could explain the reason why we're getting that outcome. Sometimes when you're using neural network or other artificial intelligence technique, you kind of identify the patterns by using previous information, but it can be quite tricky to explain how did you end up with that result. Can you talk a little bit about that?
Yes, it's very true. Yes, it's sort of the black box approach, right? It's sort of like gun generative networks. They will sort of work, and then at a certain moment they'll collapse and don't work anymore. So it really remains important to have a good evaluation metric. And we're trying to work towards that. In fact, I'd like to come to a sort of toolbox where you run your generated music to, and it'll tell you how good it is. Does it contain, a long-term structure? Does it contain like these repeating patterns that form earworms or not? There's ways to detect this, but in traditional machine learning, a lot of the papers or blogs that we see appearing, they really just say we listened to it, or they did a listening study, but that's sort of the extent of it. So I think some work needs to be done to get these evaluation metrics, and then once we have these metrics, we can maybe identify as well how fitness functions should look like in the future. Yeah. And another interesting thing, and that sort of ties in with the work we did on solos as well, is that you could use optimization to put a bigger structure in the song. Like you have the blues, you need the repeating chords. And machine learning now, it's great for generating a short snippet of music. But if you listen to a song, a 3-minute song, it can't really just be new music the whole time. There needs to be something, a pattern, and that I think that's one of the challenges that people are facing right now.
Yeah, maybe with the use of optimization, I'm not necessarily into programming as we did. You use metristics very successfully, for example, but maybe you can have a little bit more control. You can define your own set of rules. We defined at the time we call it transition rules, right? We wrote some constraints, like saying, oh, we won't have, we need this amount of nodes in this interval. We won't repeat this node perhaps this much times, and we kind of can mathematically, and it's quite intuitive, right? To add and input those features. So when it comes to machine learning other stuff, it could be a little bit more weird, maybe, right? I may be wrong. I'm just wondering.
Yeah, I think I've been urging some students to try to incorporate hard constraints in their loss function of their neural network. So there must be a way. I think other researchers like François Pachet used to be head of Sony in Paris, Sony Computer Labs, and he's now director in Spotify. So the fact that Spotify hired François Pachet also means that they are looking into music generation, by the way. And so he has also been trying to do this thing where he combines optimization and some sort of statistical model, Markov model, or something. So there's definitely something to say for that.
Yeah, right. Markov models are also an interesting option. We've worked now recently with that to generate licks, which is that sort of a phrase. So then we can build up in our framework that schedule those licks. So at some point we resort to that, studying, especially when you want to mimic a pattern. In our case, it was like a turnaround lick where you have that ending and at the same time beginning of another loop. And it's not very easy to artificially generate that. So we tried using Markov models as well. You mentioned now that there are companies that are taking interest in this type of things, and so there could be more job opportunities for those pursuing that type of career, right?
Oh yes, absolutely. I think so. So there's the big companies, Spotify, Pandora. And there's some others, often based in San Francisco. Although I think Spotify is also Norway or Sweden, and but there's a lot of music generation startups as well. So in London there was JukeDeck. JukeDeck got bought by ByteDance or TikTok. So maybe we can, in the next year or something, select some automatically generated music to add to our TikTok videos. So it is going to really become a thing, I think, generated music. We're at that stage, but I think it's not going to work out of the box. So there's going to be a lot of rules around the generated music, because if you think about it, some background music is easy to make, right? You take a drum pattern, standard, you take 3 chords and you give them a different strum pattern, and then you already have something that can, go in the background. So I think these companies will employ tricks, not really tricks, but rules to make whatever's generated fit into something that sounds more complete.
Right. So you think are we far from reaching an artificial system that generates really good music, or is it hard to predict?
Well, I think there are some systems that generate okay music. especially if you produce it nice, you give it good instrumentation, and you add some a human touch to it in terms of performance. So that's actually another problem that's very cool to solve, is how can you slightly adjust the note timing and loudness so make it the MIDI sound like it's played by a human. If you do a lot of that stuff, I think you can already get decent sounding background music. A real like hit or music that people really want to listen to, I'm not sure that will exist anytime soon, but for multiple reasons. Maybe because, well, I don't know actually. Yeah, I would say people like the fact that an artist made something, but then you see these things like on Instagram, these influencers like Little Michaela. Have you heard of her?
No.
Yeah, she's totally synthetic. It's like 3D avatar-like thing,
Okay.
but she looks pretty real. She has like 200 million followers, and she makes like
Wow.
millions every year. And she's totally fake, right? So I think if someone fake like that can get followers, then maybe there is some possibility of a music generation algorithm to get followers too.
Yeah.
The strange times that we live in. But
Yeah, maybe
but there's
the music quality can be considered questionable. I think I may be old-fashioned, I admit, but then to have many followers doesn't mean you were good. Maybe.
Oh, no. Well, I think we're getting close though. So music generation can get good output. Then if we can humanize the way it's performed a little bit, or we make sure that humans can play it, I think there's a possibility to see some AI hits in the next year.
Right, that will be exciting. I'm really looking forward to hearing, to listen to the next AI hit. Yeah, maybe the first. Talking about perception, we're discussing now. Of course, it's super hard to say what is good or bad, right? In terms of music, that is never-ending discussion. But I noticed that you did a lot of work, at least some work involving psychology, and you managed to publish even in psychology journals, and that's awesome. And can you tell me more about this type of work you've been doing other than music generation systems?
Yes. So I end up, because this is such an interdisciplinary work, I often have collaborators, which may be from other fields. So I've worked with cognitive scientists, for instance, and one study we did was to see what causes enjoyment in trance music, what kind of repetitive structures. So for this kind of study, we need to do some computational models. So we wanted to see how it related to tension in music and information content. So just a simple Markov model as well. Do those entropies relate to how people are feeling about the music? So in that kind of research team, we have someone doing the listener test, and then we have someone preparing all the computational models. So there's a lot of synergies happening between multiple fields.
Yeah, that's great. So right now, what type of work you've been doing? I think you're experimenting with different stuff. Can you comment on what is drawing your attention the most currently?
Yeah, we just yesterday finalized about 3 papers, but 2 were on music generation. One was on using hierarchical structures for music generation. So if we don't just train a model on one level, but we do it on a coarser level as well, so we can look back further, then that is one important aspect, I think, to try to get that earworm in there, the repeated patterns.
Yeah.
Repetition.
And it's all about repetition, right? We like repetition.
Yeah, it does need to repeat. So there's some neural networks that have come out in recent years, like hierarchical RNNs or self-attention, that seem to be better at having this memory effect, but we're sort of testing out how far they or how good they can be. And then another focus area is a bit affective computing. So music and emotions are very connected. We mentioned it earlier, how playing music can, helps make us feel good. But also listening to music, you're heartbroken, you listen to music to cheer yourself up. And if there's one thing that computers may not have or understand, it's maybe emotion. Now, if you watch Star Trek, even Data, so many years in the future, doesn't understand emotion yet. Right? So this is something we've been trying to somehow capture tense feelings in music and how that needs to alternate. So we're trying to condition our music generation using valence values. So how sad or cheerful do I want the music to sound? And we're trying to somehow steer it.
Right.
For this, we use some transformer network with self-attention.
Yeah, there are some known aspects, like for example, using minor chords makes it a little bit sad, and as opposed to major chords. So there are a lot of YouTube videos where the guy changed the mood of the song by transposing or like by modifying the chord from major to minor, and it sounds
right. Yeah.
So
So that's a sort of, but a little bit more expanded is what we did, because I think it's important to allow for the music to be conditionable. Maybe we don't want the system where we generate music, bam, and it's done. But maybe as a composer, you want some plugin in your DAW, like Logic Pro, and you say like, okay, generate me, a melody for inspiration that might sound sad. So you want to control over the generation. I think that's just a better idea for musicians, composers, just enhance human intelligence or make the compositional process easier.
Definitely. Hearing you saying that, I can relate totally, because I think I mentioned to you when we started our project years ago that I do pretty well at strumming, and but I was never really good in performing good solos. I don't know why. I just probably don't have the knack for it. But I did my own songs, recorded some basic stuff. But always the solo was the issue. I knew, okay, I want a solo that is in this direction, for example. And I think perhaps we are maybe far from generating the entire piece, but small parts of music that helps the bigger the song as in general. I think that's not far, right? There are even programs that do that, even for drumming and even solos. I know there are programs that do that, but maybe not that effectively in terms of guitar solos, because sometimes you really need that emotion aspect of it. So it's very exciting that you are doing this type of work, and hopefully we will get some very encouraging results in the near future.
I hope too.
So I suppose you're supervising master's and PhD students, and from all over the place. That's great. And what do they have to do to approach you, like if they want to join your program?
Well, you can just send me an email. You can find my email online, and then we can discuss. If they mention their interests or some previous work, then we can start a discussion from there. Of course, for international students, we always have to make sure we can find a scholarship. There are some scholarships available here through the SINGA program, or we have some AI fellowships as well, although they're a bit harder to get. I believe Marie Curie also sponsored incoming students. So if they write to me, and especially if they have some sort of research experience or good grades is something Singapore requires. Then for sure mention it in the email, and then we can see what kind of scholarship we can get you. I find a great thing very double, because I think in Europe professors give pretty low grades, it's sort of some of my professors were like, you get everything right, you get 12 out of 20. Only if you're exceptional you get more. But here all the students seem to expect A's if they. So I don't think the grade thing is fair, but sometimes it's just a hard constraint of the scholarships.
Yeah, I can understand that.
Yeah.
You've been a parent recently. I mean, you had a kid.
Yes.
So how that affected your routine and your job and your productivity in the last months?
Yeah. She's 15 months old right now. Well, it definitely changes your life, right? And this timing with the pandemic is a little bit strange, I suppose, in a way lucky, because on the one hand we got to spend a lot of time at home with her. On the other hand, it has been a bit challenging to get work done, either one's sleep deprived or when you're teaching a class and there's crying in the background. But we're very lucky here in Singapore. We do have a nanny for her, so she can be in the house taken care of while both of us are teaching or something. And yeah, in general, it's a great experience. I can recommend it, but be aware that you will be getting up at 7 a.m. Instead of the usual 9 a.m. or whatever people are used to. Yeah.
Yeah. But finally, I was wondering regarding that topic of music generation and all that. Have you ever experienced any type of criticism that machine cannot replace man when it comes to art and all those things?
Oh, yeah, that's a big discussion. And can machines be creative, or are we going to steal musicians and composers' jobs?
Exactly. Yeah.
Yeah. Can machines be creative? That's like a whole research area for the computational creativity field. So I wouldn't say that my systems are creative. Maybe I'd say I am creative for creating the system. I don't know. But I think it wouldn't cause a loss of job. If anything, there's been a surge in the amount of people working in music technology. And on the other hand, as I said, I think the goal should really be to allow composers to do more and allow more people to become composers. So in that way, it's really good for all of us to have this sort of technology.
Right, and this type of technology can also help musical education too, right? To if you want to explore some patterns or to illustrate some type of application or even some improvisation. Perhaps this can be used.
Yeah. If you're struggling to make music solos, then perhaps some algorithm can extract what are the necessary components of a solo, which can help you.
You can have different solos, and maybe one of them can inspire you to work from there. Sometimes you're lacking inspiration, and you can look for technological alternatives to provide you with some inspiration. And I think it's something that we have to kind of be open-minded about that. And I hope this is, in the near future, becomes something that is more of a routine, right? And maybe even exploring different types of melodies, or sometimes some things that are not really playable from a human perspective, but it can sound cool from a musical perspective. Also can be, I don't know, a path. So
yeah.
What are the challenges you think that need to be covered for one to reach that goal of generating good music?
Right. I think the generated music needs to be emotional or capable of elucidating emotions of the listener. And it needs to have this. We need to find a way to get proper structure in there as well. Make it humanized, like it's played by a human with expressive powers. Those seem to be the three main challenges, I think, that's remaining. I don't know if you want the music to be generated live or not. So we could play video games and then it changes sort of dynamically towards the environment. That would be a fourth challenge. Because as you know, optimization algorithms can be slow. So, yeah.
Yeah, I think you were the one who showed me the Gen Jam project where the guy was improvising along with the computer. That was great. And as you mentioned, if you're using serious optimization algorithms, it can be fairly slow to react. So you play something and you have to wait for a while until it gets back something. So I understand. Yeah.
That can be a challenge. I think most of these live systems, they use something like a factor oracle or a dynamic Markov model learned on the fly.
Yeah, on the fly, exactly. Yeah. So you kind of tend to repeat similar patterns that was played by a human. And you get that mood that something is really connected and the improvisation are back and forth, right? From the music, from the player and the machine.
Yeah.
Well, Dorien, it was a huge pleasure to have you here. I had a lot of fun. It's been a long time that we had a call, actually. And
yeah, it's been a while.
Yeah. And I'm very happy for you. You're doing great. You're really, really putting a lot of effort. You're very brave in exploring a multidisciplinary area that is very hard. And I'm aware of all the challenges you have to face. And now also the challenge of being a parent, which is also something that you have to adjust and try to somehow balance with your work. And I'm very happy for you. And I'll hope to see you. And actually, I hope to meet you in person one day for the first time. We still have to meet. It's been 7 years that we've been on this online relationship, if you will. But yeah, it was great. Thank you so much. Danke.
Yeah, thank you for inviting me.
Okay, so see you soon. Bye.
See you.